Okay, this is about exponential functions. At the beginning of the semester, we have talked about exponent rule, so we're going to come back to this. Remember, if we have same base multiplying, what do we do with the exponents? We add them together. And if you have the same base dividing, we're going to do what? Subtract the exponents. And anything raised to 0 power is going to be 1. And when you have a negative exponent, we need to rewrite that to become a positive exponent. We do what? We put 1 over, and then we write down what we have here, change the negative to positive exponents, okay? And if you have power over power, like this, we're going to multiply the exponents together. So try to be careful not to mix these two up. If you get confused, you can think of like if it's a to the second power times a to the third, mean you have 2 here and 3 more, right? That's why you add those exponents. But if you have, say, a to the third power square, mean you have 2 of this, right? And then you have 3 and 3 more, that's why it's 3 times 2 equal to a to the 6th power. This is a to the 5th. So if you get confused, just like write down something with simple number to remind yourself. If you have something like this, you don't have add and subtract in between, you can distribute the exponents, am, bm. If you have division without add and subtract in between, then you can also distribute the exponents inside. am divided by b to the m power. If you have an exponent like that, you want to rewrite that as radical. Whatever you're dividing here is going to be your index number. And inside, we're going to have a to the m power. So a lot of times students have problem with the negative exponents and the fraction exponents. So we view that if you get confusing. Anything raised to the first power is just itself, right? And again, if you have a negative exponent, then you put 1 over, and we write that as a to the first power, just like that. Just a quick thing, if you have, say, a raised to negative 2 and b raised to negative 3, normally we don't leave negative exponents as answer. So what you can do is you can move the b to the top and change it to positive, and move the a to the bottom and change that to a positive, okay? So hopefully that kind of reminded you some of this rule. Today we are focusing on exponential function. So exponential function look kind of like that. So you basically have a function with a base raised to x power. So the difference between this and what we have been doing so far is the unknown part is in the exponents. They say your base cannot equal to 1. And your base should be bigger than 0, a positive number, okay? Alright, so here is like a general format of an exponential function. It has certain property. If we look at the exponential function graph, like here, we can see it's going forever to the left and to the right, right? It's like smooth and continuous, so this is kind of a polynomial function. The domain for this, because it extended forever both sides, is going to be negative infinity to positive infinity for your x values. For the possible y value for range, it's going up and down, right? It looks like going up forever to positive infinity, but this one is settled to here. So it looked like it has one of those that we talked about last time, like an invisible line guiding the graph, which is a horizontal line here. So we call that a horizontal asymptote. What is this horizontal asymptote look like to you? It look like for the y value, it equal to 0. So it has a horizontal asymptote. If that's the case, it means like y will get really close to 0 but never touch 0, so we use parentheses, and then it goes forever to the top, so it's positive infinitive like that. Does it have an x-intercept? X-intercept cause the x-axis, right? Does it cause the x-axis at all? It doesn't look like it, so we don't have an x-intercept. Does it have a y-intercept? Does it cause the y-axis? It looks like it causes here, which is y equal to 1 when x equal to 0, right? So it has a 0, 1 here. The graph have 3 points, very distinctive points. It has 0, 1 for all the exponential functions. It has, when x equal to 1, then the y part would equal to whatever base it is. And then when it's x equal to -1, the y would be 1 over whatever the base is. Okay? Alright, the graph is both smooth and continuous. So from the last section we talked about, this is considered as a polynomial function. Alright. Okay, so we want to try to grab it by hand, at least for one of them. Let's try it. So we have a function that is exponential function with a base of 2 raised to x power, okay? So how do we grab it by hand? Let's try. So I'm going to need to plug in different number for x. So I have some negative exponents, some positive exponents. So if I plug in -2, it means 2 raised to -2, right? What would that be? When you have a negative exponent, basically means you're going to put 1 over, right? And then you can write that as 2 to the second, so it's 1 over 4, right? Or 0.25. If I have 2 raised to a -1 power, then it's going to be 1 over 2 to the positive 1 power, right? So it's just 1/2 or 0.5. And how about 2 raised to 0 power? 0 power is going to be 1. And 2 to the first power is 2. 2 to the second power is 4. So we have all our points, right? 2 and 4. So using those points, we can grab it over here, right? Let's see. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so I have 0 and 1. I have 1 and 2, 2 to 4. Okay, over here. 1/2, 1/4. So kind of look like this. So it looks kind of like what we have with the general form, right? Over here. So what domain do we have? So again, it's going forever both sides. So it looks like negative infinitive to positive infinitive. And the range, again, it looks like guiding from y equal to 0, so 0 to positive infinitive. And then the point it has, like what they say here, 0, 1 is one of my point. When x equal to 1, y equal to the base, which is 2 here, right? So 1 and 2. And then when x equal to -1 is 1 over the base, which is 1/2, right? Let's go -1, 1/2. So we have all the correct characteristic of the exponential function. It also have a horizontal asymptote of y equal to 0, right? It has an invisible line for here, y equal to 0. Okay, so you can also use the calculator to check, but we learned last time we can do transformation. So if I'm using this graph as my base, 2 raised to x, I can see for the whole function I multiply negative in front of it, right? So all my y value will become negative y value, so it flipped down here to reflect over the the y axis. And then if I cover this, like my y value equal to 3, right? So if y equal to 3 means all my y value will go up 3 units, right? So I can see the graph is going to be flip, but go up 3 units for y, kind of like that. So we can use the calculator to try, and I kind of want you to make sure how to do it also. So to graph, first we will go to y equal to, this is negative, so make sure you use your negative sign, and then don't use the subtraction sign, and then put 2 raised to, so the caret top button raised to x, so we found out x button, which is here. And then make sure like you don't type +3 in the exponent part, okay? I will use the arrow key to move it to the side, and then add a 3 on the side like that. Hit enter, so the function is inputted in there. You can see it. Okay. Okay, like that. And then I can do graph, right? I can zoom in and out if needed. So kind of like what I said earlier, we use this graph, we flip it, reflecting it, because multiplying to a negative, and all the y value need to add 3. So instead of have a y equal to 0 as my horizontal asymptote, I will move that to y equal to 3 as my horizontal asymptote for this graph, instead of like 0, 1. If I flip it, it would be like this point here. So this point has to go up 1, 2, and 3 units also. So if you are really good with the transformation, you can do it by hand. For the business math class, they also allow you to use the calculator to identify the graph. So I just want to show you real quick. So if you need to sketch it, oops, sorry, it would be hitting 2 here, like that. So that would be the graph for that. Okay, so let's look at the next page. So here has some of the important question I really want you to know how to do, is solving exponential functions. For this type of equations, one of the strategies we have is we try to make both sides with the same base. If you have just one term on each side with the same base, then you can cancel out the base. So that's the basic strategies for this. So we have 3 examples here. We're going to try to do this together, okay? All right, let's try with A. Number 2A. We are solving 9 raised to x equal to 27. Because I want them to have the same base both sides, one term on each side, so I can cancel the base. What would be a good base? 9, this can be like 9 to the second power is already 81, right? So 9 is not a good number to change to the base 2. I need to go a little bit smaller. So a smaller number for this may be 3. So we can try on the side if you're not very good with this yet. So this would be 3 times 3, so it means 9 equal to 3 to the second power, right? And 27 would be 3 times 9, 3 times 3, right? So it's going to be 3 to the third power. Are we okay with that? So I'm going to replace those numbers with this, so they have the same base, all right? So 9 now becomes 3 to the second power, and 27 becomes 3 to the third power. And on the left hand side, I already have an x here, right? So the 9 replaced with 3 square, and I bring the x here. 27 replaced with 3 to the third power, which is looking like this, right? That's what I want. Same base both sides, one term on each side. So I'm ready to cancel out my base like here. So I have 2x equal to 3, and then I just need to solve for x, right? Divide 2 both sides, so x equal to 3 over 2. And if you want to, you can plug it back in here. It should check with equal to 27, okay? All right, so that's the first one. Let's try the second one. Number 2b, we have 8 raised to negative x plus a 14 equal to 16 raised to x. So you want to think about what is a good base to change to. Sometimes people may say, okay, 16 can be 4 square. but can I change 8 to 4 to some power? Like 4 to the first power is 4, 4 to the second power is 16, so I cannot get them to have 4 as like my base, right? So instead of 4, I may need to go like smaller for them. So I can think of 8 can be broken down as 2 times 4 and 2 times 2, which means this is 2 to the third power. And 16 can be broken down as 4 times 4, 2 times 2, right? So 1, 2, 3, 4. So 2 to the fourth power. Are we okay? So we can replace those numbers with that. So 8 is 2 to the third power and 16 is 2 to the fourth power. And originally I have some number there, some stuff here, which is the whole thing, negative x plus 14. So make sure your 3, the third power, multiply to this whole exponent, okay? And then x here. So now I have the same base, both sides, one on each side. I can cancel it out, right? So cancel that. Now we have 3 times negative x plus 14 equal to 4x, right? And then you can distribute this in here. And we got negative 3x plus 14 times 3 is what? 14 times 3 is 42 equal to 4x. And then we just need to solve this, right? So adding 3x both sides. 42 equal to 7x. Divide both sides by 7. X equal to 6, right? And then you should be able to plug this in and this should check. Alright, so they're not too bad. Just make sure you get both sides with the same base, right? Hopefully you can do that. Okay, number 2C. We are solving... what is the question? Okay, we are solving 8 raised to x power equal to 1/2 x minus 2. Okay, so look like we're going to change them to 2 as the base, right? This is 2 times 4, 2 times 2. We already know 8 is 2 to the third power. How about 1/2? So when you have 1 over a number, we remember this is what kind of exponents? A negative exponent. So it's 2 raised to negative 1. Alright? So now we can change them. So 2 to the third power, this is 2 raised to negative 1. And then copy down what we already have. This is an x here. This whole thing is x minus 2. Okay, so make sure they're together. We cancel the base. 3x equal to negative 1 times x minus 2, right? So if you distribute this in here, then we're going to have, what do we have? 3x equal to negative x plus a 2, and then add x both sides. 4x equal to 2, divide both sides by 4, so x equal to 1/2. So hopefully that makes sense. So you probably will see some of this question on the exam. We will test you over that. Going back to our handout, let's do one more question for this video. This one is like using the base e. Remember we talked about e is a natural number if you use your calculator. E is related to the natural log ln, so it's on top of here. So if I want to access e, I need to use the blue button and tap in the ln. If I put into the first power, equal to 2.71828 something, right? Oh, I'm sorry, you cannot see. So, and if you have a scientific calculator, it's a little bit different. It's still on top of ln here, so I have change to the yellow button E, but instead of an exponent on a scientific calculator, usually they just put the number next to it, so you will get the same number. So make sure you know how to use your calculator before the exam. Practice a little bit. Okay, so they want you to graph this. This is the natural number, like the pi, it go on forever. E is they say 2.718 something, right? All right, so if I need to graph this, I probably need to use the calculator for this guy. 2 to the first power is like a 2.72. How about e raised to the second power is going to be rounded to 7.39. And then e raised to 0 power, anything raised to 0 power is what? 1. E raised to the -1 power, so make sure you use your negative sign. 1 equal to 0.37, and then e raised to -2 is going to be 0.14 about. So when you graph it, you will plot those points. So again, 1 here, 1 is 2, x equal to 1, 2 point something, x equal to 2, 7 point something, -1.37.14. So it's kind of close together like that. So this is the f of x raised to equal to e to the x power. So if you have like some kind of transformation graph, you can try to do either transformations, or you can try to use the calculator and see how it looks like. Okay, all right, so the next video would be about some application problem.